This is problem number 4 from section 8.2. It says one side of a parallelogram is 10 feet and another side is 12 feet. The angle between these two sides is 44 degrees. Find the lengths of the diagonals to the nearest tenth of a foot. Well, the first thing we need to do to start this problem is draw a parallelogram and then talk about it. So let's draw a parallelogram. And let's label what we know. We know that now we've got, in a parallelogram, you've always got obtuse angles and you've got acute angles. Well, 44 degrees, that's obviously going to be the acute angle. So our 10 feet and our 12 feet are going to be right here with this 44 degrees. Now, one of our diagonals is going to be a little longer than the other diagonal. And let's talk about why. So first of all, the diagonal between the obtuse angles. The obtuse angles, I mean, the reason they're obtuse is because these two sides have been kind of scrunched in toward each other. So this diagonal between them is actually shorter than the diagonal that is on the acute angles, because you know, if we think about taking that square and kind of stretching it, that's how we get the acute angle there. So we kind of stretched a square a little bit, you know, shifted it, and this is diagonals gotten longer than this diagonal here. So in our problem, we're going to actually end up with two different triangles to kind of deal with. So let's go ahead and draw those because we want to find two different diagonals. So for the shorter diagonal, which is here, that's this triangle there. So we're going to use this triangle, try and draw it the exact same. Where it's 12, this is 10, this is 44 degrees. And this is our, we'll call it the shorter diagonal. And then let's go ahead and draw the other triangle. The other triangle that we're going to use is going to be right here. Now, we know that in a square, if you add up all the angles, in a square it's 90, 90, 90, 90, so that's 360 degrees. In a parallelogram, it's also 360 degrees. So if we have 44 degrees here, we know that this up here is also 44 degrees. So if we want to find the angle here and the angle here, we can do 180 minus 44 minus 44, and then that'll give us the total angles left, right? So what we'll do is when we do the 180 minus 44, we get sorry, not 180. We don't want to do 180 minus 44. We want to do 360. I screwed that up. 360, because that's what I was just talking about with the square. 360 minus 44 minus 44. So 360 minus 44 minus 44 gives you 272. And we want to take the 272 and split it between these two angles, because each one's going to get half that. So then we do 272 divided by 2, and 272 divided by 2 gives us 136 degrees. So this angle here is 136 degrees. And so is this one up here. So we can draw this other triangle then. We know this side's 12, this side's 10, this side's 10, this side's 12, this side's 12. So we can take this triangle and draw it as well. So let's go ahead and do that here. This is our obtuse angle of 136 degrees. This is a side of 12, this is a side of 10. And we're looking for, this would be our longer diagonal. Okay, let's go ahead and label these two triangles real quick so that we can use our law of cosines to figure this out. I'm going to label this. Let's go ahead and label it A, B, and C. That means that this is little c, this is little b, and the shorter diagonal is going to be little a. So let's go ahead and take a look at our different versions. We want to find that shorter diagonal. Which version do we need? Well, we need to find a, so it makes sense that we would use the a squared equals b squared plus c squared version of this, because we already know b and c, and we know that the angle A is 44. So this formula looks like it's the best formula for us to use. Let's slide that formula up and let's go ahead and use it. So a squared equals b squared, which was 10 squared, plus c squared, which is 12 squared, minus 2 times b, which is 10, c, which is 12, and that's cosine of 44. So a, and when I do the root of each side, will equal the root of 10 squared plus 12 squared minus 2 times 10 times 12 cosine 44. So that means that a equals, and remember a stands for the shorter side. Let's go ahead and throw that in the calculator. We do 10 squared, and I like to piece it together, plus 12 squared minus 2 times 10 times 12 times cosine 44. And then 71 is what's on the inside of the radical. I need to actually do the root. And that gives me a length of 8 and they want us to round to the nearest tenth, so that's 8.4. So that's 8.4, and I'm going to label this the shorter side, or shorter diagonal. So now I need to find the longer diagonal. Well, if I label these, and let's label them the same way, so this is A, this is B, this is C, so this is little c, this is little a, and this is little b. So in this case now the longer side is little b. Remember, you can label these however you want. It just depends on what version you're going to use for your law of cosines. So I am trying to find b. I'm going to use the b squared equals a squared plus c squared minus 2ac cosine b version of this formula. So let's go ahead and use that. I'll just slide this up a little bit, back to the top, and we're going to say b squared equals a squared, which is 10 squared, c squared, which is 12 squared, minus 2 times a, which is 10, times c, which is 12, and that's cosine of that obtuse angle, which is 136 degrees. So we can do b equals the root of all that, which is 10 squared plus 12 squared minus 2 times 10 times 12 cosine 136. So b equals, let's plug that in the calculator. Again, I like to piece it all together, so 10 squared plus 12 squared, enter, minus 2 times 10 times 12 times cosine 136. That's what's on the inside of the radical, so I need to do the radical of that answer, and I end up with 20.4. And this is the longer diagonal. So if I look at my original picture, the diagonal from here to here, right, from obtuse angle to obtuse angle was only 8.4. That's a shorter diagonal. But from acute angle to acute angle, that diagonal is 20.4. Those are our two answers.